So welcome to this webinar on generative AI and data standards to optimize operational efficiency in capital markets. My name is Gabriel Carlsen, Senior Director for FinTech and Digitalization at ICMA, and I'm delighted to be joined today by Rahul Gupta, Financial Officer, Isha Asala, Data Scientist within the Asset and Liability Operations Department at the World Bank Treasury, as well as my colleague Emma Thomas, who runs ICMA's Bond Data Taxonomy Working Group and ICMA's AI in Capital Markets Working Group. It is great to see that we are joined today by well over 100 participants. Today's webinar will showcase how generative AI can be applied to resolve long-standing pain points in fixed income markets, how to streamline reconciliation processes, prevent settlement fails, and enhance liquidity management. In the webinar, we will also address the role of standards, notably ICMA's bond data taxonomy and why it matters, here in the context of leveraging the latest AI advancements. Promoting well-functioning cross-border capital markets that support sustainable economic growth is at the heart of ICMA's mission. Digitalization and new technologies, whether AI or distributed ledger technology, impact the entire value chain of international debt capital markets. ICMA's focus is to promote market consistency through common standards, provide guidance, but also share learning experiences. Thank you for joining us today. I hope you enjoy the webinar. And with this, I now hand over to my colleague Emma Thomas.
Thank you, Gabriel. Before we get started, we do just need to bring your attention to a code of conduct that we have for webinars and virtual meetings. All of this will be available as well on the recording that is published after this webinar too. And this is just to say that it is important not to break any of this competition law and to use good judgment when navigating through a webinar. And looking at the agenda today, I'm pleased to be with Rahul and Isha to go through how generative AI is being used for operational efficiency and data standards in capital markets. This is a big area of focus for us at ICMA as well. And the collaboration has been a really exciting time for us looking forwards to the future of capital markets. So today we'll be looking in particular at Project SHASTRA, which stands for Sharing Capital Markets to Enable a Single Source of Truth for All. And in essence, it's a Gen AI model which is used to extract data from dealer term sheets and convert it into standardized formats, such as the BDT. So in the order of proceedings, we're going to start looking at the problem areas which sparked this idea and this build. Then we'll take a look at how the model was built, how exactly it solves the problem, and how it also implements ICMA's bond data taxonomy in the process to reach that golden source of trade data, which is so desired in the market. This is also very important for preventing things like settlement fails, enhancing liquidity management, and also creating a more efficient capital market for all. So finally, we'll look at what we can do taking this project forward, the areas for collaboration with the World Bank Treasury and ICMA, and the future of AI adoption in capital markets and what this looks like. So we have a lot to get through. As has been said, we welcome questions in the Q&A box at the bottom of the screen, and we'll address those at the end of the presentation. So over to Rahul to get us started.
Thank you, Emma, and thank you, Gabriel, for this opportunity, and thank you, ICMA, for the opportunity to present our in-house built SHASTRA solution for shaping capital markets and generating operational efficiencies in capital market operations. So as Emma mentioned, SHASTRA, as we call it, stands for Shaping Capital Markets by Enabling a Single Source of Truth for All. So when we talk about SHASTRA, when we try to understand the value of SHASTRA, we must first recognize the challenges which are faced across the entire capital market ecosystem from all the participants in the ecosystem in the value chain, starting from issuer all the way to the eventual investor. The first of these issues or the challenge faced by market participants is data inconsistency. So issuers and investors, they interact with dozens of dealers. In the case of World Bank itself, we deal with over 20 plus dealers. Each of these dealers, they use different term sheet templates. They have varied definitions for the terms. They have inconsistent data formats. This leads to a lot of fragmentation. And when we talk about this fragmentation, it leads to misinterpretation and also leads to avoidable operational friction, which can be avoided. The second challenge, which is faced by market participants, is the redundant data capture. The issuers, paying agents, the custodians, the data providers, they all create and manage the same data, the same transaction data separately in their own systems, in their own way, in their own using their own terminologies. This leads to a lot of duplication and results in manual work, higher costs, and increased likelihood of discrepancies when you are capturing so many data points at each and every stage. And when I talk about data inconsistency and the redundant data capture, it eventually leads to data accuracy and the risk inherent in data accuracy. So when information is inconsistent or manually re-entered, there is an opportunity for errors to creep in that process. And this inaccurate data might lead to mispricing, reporting issues, and ultimately financial losses, potential for financial losses for those parties or stakeholders who are relying on the accuracy of this underlying data. So I wanted to showcase the current landscape, which is followed at the capital market process at the World Bank. So this, as you can see the flow of each data point or the term sheet as it goes through the various processes internally. And this is how typically a capital market transaction flows at the World Bank. So as I mentioned earlier, this manual and repetitive process has a potential or it involves multiple handoffs and repeated data handling leading to potential data issues. By the time a dealer sends the term sheet to our trading desk, followed by the trade review, which is performed by our operations team, the drafting of the final terms by our legal department, and sharing of these final terms with our issuing and paying agent and the clearinghouse, as many as 8 copies of the same data are created in different systems. And each of these different systems, when the data is created, they involve manual input, manual checks, and manual reviews at each and every stage of this process. So what are we eventually getting with these legacy workflows? And these legacy workflows are so fragmented that this creates opportunities for operational inefficiencies because of the repeated manual process at each and every stage, each and every touch point within this process. This also leads to inconsistencies arising from multiple versions of the same data being created or being saved in different points at different systems at each and every point. And eventually this leads to higher operational risk because there is a possibility of errors, delays, or even compliance gaps in this process. So this leads us to the genesis of Shastra, why we thought about Shastra, creating a single source of truth for all. So when we considered all these challenges, which I highlighted earlier, there was this one fundamental insight which was coming out in this whole current workflow. The insight being that the dealer term sheet is the primary source of truth for all the issuance data. So the obvious question arose that why not extract this information once and for all in a unified and universally acceptable format and share it with all the downstream participants, all the stakeholders who are relying on this data. By doing this, can we not eliminate inefficiencies in the process? Can we not create one data copy, reduce manual reviews, and unlock massive efficiency gains across the whole trade life cycle? So this eventually led to the birth of Shastra. And as Shastra was conceptualized, it was thought that why not use the advancements in generative AI to extract this trade data directly from dealer term sheets, regardless of the template or format which the dealers are preparing these term sheets in. And to ensure the accuracy and precision in this process, the AI output will also undergo a human in the loop review process. And when we thought about this solution, that it should be a low cost solution, easily implementable by everyone. So we thought that why not use commonly available and secure technologies such as Microsoft Azure, and then we are using Python based tooling. And on top of this, we follow World Bank's internal integration frameworks when we talk about different processes and different systems. Once this data is extracted, validated by human in the loop review, and we create a single digitized golden copy of the trade data, this clean data set becomes usable across all the internal World Bank Group processes. This can also face external facing workflows, and then it can also be disseminated to all relevant stakeholders who are all the market participants, all the stakeholders, all the counterparties who are part of this capital market process. And this was not the first time a solution like this was considered. There were previous iterations and alternatives that were considered, but they kind of didn't meet the expectations, or they always fell short somewhere. The first of these things which we considered was the OCR, which we know as the optical character recognition models. These models had limited effectiveness because the dealer templates are so varied. The structures inside them, the data structures embedded inside these dealer term sheets are so inconsistent, and then they cross-reference between bond and swap and the notes, so within the same term sheet. So it becomes cumbersome for an OCR model to come or overcome these challenges. Then we also thought about digital issuance platforms, but because these dealers, they use different platforms, and there are serious concerns about confidentiality and data governance challenges because the data issuance or the issuance data being a proprietary uh, information and sensitive information belonging to the issuer. So these data digital issuance platforms didn't meet the cut either. Then we thought about digital bonds, um, and we did some digital bond issuances in the past. Though these solutions, the digital bond solution, streamline the downstream processes, but they didn't meet the expectation, as in they didn't solve the core documentation and the data extraction challenges which were existing at the source itself. Um, so here comes Shastra, and I can say that Shastra's value proposition lies in four core pillars. Shastra tries to deliver impact across the whole entire capital market life cycle through four key pillars. First of all, it eliminates data inconsistency because we are extracting trade terms directly using AI from the dealer term sheets. So in a way, we are standardizing issuance data regardless of the template which the dealer is using, regardless of the format, regardless of the conventions which are being used in the term sheet. As such, everyone in the whole value chain works off a single consistent data set. The second pillar is that Shastra enhances operational accuracy in the whole capital market process. When we automate trade capture using Shastra in the Treasury's core capital market system, we not only reduce manual entry, we also reduce the potential for human error. We accelerate processing of this data, and this improves both productivity and reliability eventually. Then we also strengthen controls around the capture of this data because we are uh, in talks with our issuing and paying agent, and we are performing automatic or automated reconciliation of the issuance data with our issuing and paying agent. So in a way, we are reinforcing downstream governance in the whole process. We are improving accuracy and enhancing auditability of this trade data, which is captured through Shastra in our systems. Then the fourth pillar being we are driving consistency and efficiency. So once this data is validated by human in the loop, this digital golden copy can be seamlessly disseminated to all downstream participants or stakeholders in the value chain. This is promoting faster workflows. This is reducing duplication. This is ensuring that everyone receives the same trusted information and rely on it for all their needs, for all their documentation. So Shastra, the basic notion or the basic underlying block for Shastra is the data. And where is this data residing? It is residing in the term sheets. All the trade economics, the structure of the underlying transaction, the legal documentation, the connection between various systems, and the eventual information that is available to investors is driven by the term sheet, which is coming from, or this data which is coming from the term sheet. Yet today, we recognize that this data is fragmented and it is interpreted differently by each and every participant in the life cycle. So one of the biggest challenges in today's capital markets is that every dealer is speaking a different language when it comes to these trade terms. Even for the same type of transaction, dealers are using different field names. For instance, one dealer is using issue price, another one is using reoffer price versus reoffer yield for the same terms. Then they are using different structures in the term sheets. Some dealers use tables, while some do not. Sequencing of paragraphs within the term sheet is different among dealers, and they also follow mixed bond and swap layouts. Then dealers use different conventions in the term sheets. For instance, they use different decount conventions. The reset language for conventions is different. Even call option structures follow different conventions. And we have realized that dealers are using different terminology for identical concepts. For instance, they use fixed rate note versus fixed rate coupon, or straight or plain vanilla bond for same kind of instrument. And they have different ways of referencing related terms. So as I mentioned earlier, the swap terms, they refer to the terms which are inherent in the note, for instance. So this creates another challenge. So as a result, each and every term sheet, though they describe the same product, they look different, they read differently, and need to be interpreted in a consistent manner, right? So all these variations create the need for repeated human judgment. It creates the need for manual mapping at each and every process, and reconciliation, which needs to be performed at every step of this process. So this highlights the challenge which the capital market participants or capital market operation participants are facing in the today's world. So with this, I'll now pass on to Isha for the underlying architecture for Shastra.
Good morning, all. Thank you, Rahul. Now that we've covered the what and why, let's shift gears and look at how we actually bring the solution to life. So on the screen, if you notice, we have the technical architecture of our components. The animation takes you through how the data flows from the term sheets through different data containers and different review processes. But on a higher level overview, the entire workflow of Shastra consists of 4 main stages. The first one being the LLM, or the generative AI-based data extraction from the term sheets. The extracted data is then pulled into a human-in-the-loop interface where the user is capable of reviewing and validating the AI extracted data against the term sheet. The next stage is this data, once it's submitted for ingestion into our treasury system. We are capturing all of this data into an XML file. This file is only to comply with the input requirements of our treasury system workflow. And the final step is for this data to be sent over to our internal treasury system workflow that ingests the data and creates security bond and swap objects for this data and returns back the acknowledgement for these objects. From a technical perspective, our project consists of 3 main components. The first one being the web app, where that hosts the AI. So the user has access to the web app and is able to upload the term sheet onto the web app. The next, and this web app also has the human-in-the-loop interface where the extracted AI data flows for human validation. The second component is the Python daemon, which acts as a bridge between the web app and the treasury system. So the Python daemon pulls the data and creates an XML file that is sent over for ingestion by the treasury workflow. So welcome to the heart of our solution, aka the AI. So we're teaching our systems not just to read documents, but to understand them. This workflow, or this page here, transforms a static 5 to 7 page PDF into a dynamic queryable intelligence, allowing us to ask complex questions and get instant answers. So the step 1 of the process is data ingestion and initial storage. What happens here is the process starts with a user submitting a prompt, question, or instruction, and a PDF document, which is the term sheet. This input is ingested by the SHASTRA system and stored in a secure storage in the blob. At this stage, the data is still raw and unstructured, a digital file that is human readable, but not yet accessible to AI for analysis. Step 2 is the intelligence document processing. So what happens in this stage is an Azure trigger function activates the Azure Doc intelligence and layout analysis on the document coming from the blob container. This is the transformation point, turning the unstructured data into structured data. Phase 3 or step 3 is vectorization and semantic search indexing. So another Azure trigger function sends the structured data and the layout of the document to the Azure AI search, where it is vectorized, converted into numerical representations that capture the semantic meaning of the information. Here, the data is mapped into a multidimensional space. This is where the data speaks the AI language, which we will see further in the next slides. The AI X-ray vision. So what really converts the document to data is Azure Document Intelligence. So as you can see, the various components of the document structure are analyzed. The header, the subheader, the table structure, any key value pairs, as they are recognized, they are stored in this table, which it uses to map back to retrieve information from. So we start with the standard financial document. On its own, it's just a static image or PDF, but we are creating a mini database from the static image. So the AI isn't just seeing random words. It's learning the document's blueprint, which is the first step in distinguishing a title from a data point. So the next step, or the final step for the generative AI analysis, is the AI vectorization. So what you're seeing here is a mock AI embedding visualizer. So after we upload a mock term sheet, the visualizer picks up 48 key value pairs, and you will notice that each of these are transformed into 3D vector space with three-dimensional embeddings. So this is sort of a high view visualization of how these embeddings would look in real space. So what happens after these words are mapped into space? So let's say the query is, what is the issue amount in the document? The vector representation of the query itself looks something like that. And with that vector representation, what AI search does, it tries to pick up the key value pairs or values that match very closely to the vector representation and picks the top match based on the distance, the closest distance of this vector with the vector of the query. Again, these embeddings are only for visualization purposes. In real life, these embeddings can be as high as 1,500 or more dimensions. So then how did we end up using a general generative AI model into a financial analyst? So we needed a lot of rigorous testing to come up with a good prompt instruction that helps AI walk through these term sheets. And these steps go through each of these processes. The first step is describing the nature and structure of the documents. So imagine this as giving AI a map of what it is going to look at, which is the term sheets, and what is the structure and what is the understanding of these term sheets. The second step is dividing the document into sections and tasks. For example, in our term sheet, it would be a bond section and a swap section. And dividing the tasks is for AI to understand if it's looking at dates, if it has to retrieve currencies, notional amounts, etc. Defining the terms occurring in the document under bond and swap. So giving basic definitions how each term is different from one another and where these definitions appear in the term sheet can add more context to the term and help AI pinpoint with the given context of the term sheet information. The next step is establishing dependencies between the financial terms. So for example, in some of the term sheets that we've seen across, some of the swap terms have values that refer to the values from the bond. And so establishing that dependency between the bond and swap is key. Examples, and examples. Sometimes when the term sheets have a lot of terms that are similar in nature or similar in format, AI might struggle with some of the extraction. And so giving examples of how these values may appear or how they might look like in the term sheet has helped us improve the accuracy of our results for different terms. The next rule is my favorite, it's setting formatting rules. Since we would like to use a solution like this in real world, in production, it's very crucial for us to have the AI response as consistent and standardized as possible. So some of the formatting rules we set, for example, would be for the AI to respond in one JSON object with bond terms and swap terms as subdictionaries. And the final and the most unavoidable step is tuning and testing and testing and tuning. So addressing the elephant in the room. So the term sheets come in different taxonomies, shapes, formats, right? And how does AI help SHASTRA make the final interpretation? With the definitions of the terms and the formatting rules that we define, this has helped our AI understand and pick up the values occurring in different situations across different term sheets and has been able to give us very accurate value across these different term sheets. So with all of those technical components in place, let us have a look through how this process works from a user's perspective. The first step would be uploading the term sheet and viewing that on the web app. So what you're seeing is a global view of our review page. This is where the users can look at the deal name, when deal has been reviewed, and who it's been reviewed by. And as you can see, you're able to see the statuses of the security, bond, and swap objects that have been created as part of the process for final verification. This is the human in the loop review page. On one side, you are able to preview the term sheet. On the other side, you're able to see all the AI terms that are pulled into the human in the loop page. There's 3 different colors for these fields. The fields in blue are strictly AI extracted or AI generated fields. The fields that are colorless or white are fields that are that don't explicitly occur in the term sheet, but these are derived terms that are necessary to make a complete and accurate trade booking for our internal downstream processes. The field in the yellow, as you can see, has been edited. The user has the ability to edit or make changes to any of the fields that the AI may have missed to extract, or if there's any information that has to be added that doesn't occur by itself in the term sheet. And the data set is dynamically updated before it's ingested into our Treasury system. This is just a view of how we format the XML file for our Treasury ingestion after the AI extracted data has been validated. And the final step of the process would be the ingestion, of course. So this is just a mock-up screen of how we expect and how we see our data that has been reviewed and submitted on our Treasury system. So it's now time to go beyond the slides. Here's a sneak peek at how our solution works in practice. So this is the login page of our web app. The access to this web app is controlled by our Treasury system. So the first phase would be uploading of the term sheet. After you select the right repository, you would be prompted to select whether this is a new deal or an existing deal. What is the trade type of this deal? And after you choose the right name for the document, you would be asked to select a file from your local directory. This opens up a preview screen for to check whether the bond and swap are intact and coherent during submission. So after the term sheet has been uploaded and is ready for AI extraction, we move to the deals extract page. As you can see, the recently uploaded term sheets always show up at the top. And once you click on extract, this data is processed for human in the loop review, and the data is refreshed. So in the review page, you're able to see that the data is pulled against the term sheet, and you're able to verify the information accordingly. So we've divided our data into security, bond, and swap section. If you can notice, there's some fields with those red markers against them. This is just a guardrail to ensure that none of the mandatory fields for the trade booking or none of the important trade economics are left empty or submitted null during ingestion. So we have also implemented drop-down lists for some of the fields. And as you can see, we have also implemented multiple hedging. So if a bond comes with multiple swaps, then you have multiple swap sections for where this data would be populated. This is a drop-down list for business day calendars and for listing conventions. So this is just a guardrail to ensure that the nomenclature of these individual terms itself does not differ when the user enters any data or submits any value for ingestion into our Treasury system. So once the data is reviewed and is submitted for processing, it will then take you back to the deals review page where the review status is updated. And this is, again, just the markup screen of how we would then see the security, bond, and swap objects created in our Treasury system. And with that, I will pass it on to my colleague Rahul to continue with the rest of our presentation.
Thank you, Isha, for that very insightful peek into our SHASTRA tool. So the bond data taxonomy. So as I mentioned earlier, Shastra's vision is to create a single source of truth for everyone, all the participants in the capital market value chain. For that vision to materialize, it is natural that the underlying trade data, which we are calling as the truth, must be interpreted consistently and uniformly across all systems and across all stakeholders, each and every participants in the value chain. So what are we doing to make this vision possible? So to achieve this, Shastra is leveraging ICMA's bond data taxonomy by translating dealer-specific terms into a single unified vocabulary, which is provided by ICMA's bond data taxonomy. In that process, Shastra applies enumerations in the design itself to ensure consistency and prevent deviation from the usually followed conventions. This in turn produces one clean standardized data set, regardless of how the dealers chose to describe that particular trade. So in short, what are we trying to do? We are trying to, the different dealers that are speaking different languages, but we are trying to make sure that Shastra ensures that one copy is received or it is read in a consistent format by the World Bank. And what emerges is one consistent source of or the digital golden copy, like one truth. And how does leveraging bond data taxonomy help us in this process, or what kind of advantages it has provided to us? Is first, we didn't need to reinvent the data dictionary. So Shastra avoids the need to build a new data model from scratch. Instead, it relies on a globally recognized taxonomy that already reflects industry accepted terms and structures. And secondly, it is enhancing interoperability because BDT is a industry standard. Data is structured under this taxonomy. When it's structured under this taxonomy, it allows different technology platforms to talk to each other and communicate seamlessly. So this in a way ensures that the different systems which are speaking different languages are able to talk to each other. So for instance, the issuers, dealers, the data providers, the regulators, and downstream systems who are eventual consumers of this data, they are able to talk to each other. So in a way, by grounding Shastra in the bond data taxonomy, the platform or the tool, our solution has ensured that the data that is extracted, validated by human in the loop, and shared by to all participants is not only accurate, but universally understood and is future ready for all processes. So this brings me to the next step. And for this, I'll pass on to Emma.
Thank you, Rahul. So we'll take it back a little bit just to provide some context on ICMA's bond data taxonomy for those of you who this may be your first time hearing about it, or you just want to gather some of that historical knowledge on the creation of the BDT. So ICMA set about creating a common language a couple of years ago built on industry consensus. So our members, our stakeholders in the industry came together to collaborate with us to create this common language of core bond data information. And it represents this in a machine readable manner, which you just saw on the slide before that Rahul showed. So typically, it's the core information included in a bond within the BDT, and it also has a DLT extension to it as well, which includes the core information for a DLT bond too. And like I say, it was built as part of the broader efforts of the industry to solve problems such as the lack of interoperability in the market, the fragmentation, and just to facilitate straight-through processing between multiple different systems or solutions across the entire life cycle. So from issuance through to the distribution process, the core information included in the BDT can be used. And with that, we also have a bond data taxonomy working group, which I'll come on to talk about in more detail. But if we just go to the next slide, please, Rahul. With the bond data taxonomy, you can find more information about it on our website. But within the download of the bond data taxonomy, you get 4 different components, which I'll just talk you through quickly now. You get a reference sheet, which includes the Excel spreadsheet, which helps to guide you through the use of the bond data taxonomy in a more readable format. And it includes the definitions of the core bond information that's included. You also get the XML schema definition files that we have just seen, which include that machine readable language and structure that is used for the interoperability aspect between different potential solutions in the market. And we also have a number of example files of how it is implemented, as well as a user guide, which talks you through how to get started with the BDT and all the different parts that are included. So the BDT is available to both members and non-members, and it is because it is for the benefit of the market. So you can just download it on our website, take a look, and also reach out to us if you have any queries or any questions that you want to talk about going forward. So if any of you do want to know more, we are more than happy to sit down and have a chat with you at ICMA to talk about the BDT in more detail. And there are also video tutorials online, and we will also come on to talk about some of the ways it's been implemented across the trade lifecycle in more detail at the end of this presentation. But that is just to say that's a real quick introduction to the BDT and its inception and why it was created. So with that, I'll hand back to Rahul and we'll circle back to some other use cases later.
Thanks, Emma, for that very insightful details on the bond data taxonomy. So as I mentioned earlier, one of the pillars of the value proposition of SHASTRA is the standardized data dissemination layer, which is built into SHASTRA architecture. So once the source data is extracted, validated, it creates a digital golden copy of the data set that becomes the authoritative representation of the trade itself, the trade structure, the underlying data. So this data resides, once it is extracted by AI, it is validated by human in the loop review, it is captured by our treasury core system. So this resides in the World Bank's data lake, and it's ready for dissemination in a unified format. From here, SHASTRA enables seamless automated dissemination of this data to all downstream participants. And this data is a trusted source or the digital golden copy of data, which becomes available for all downstream systems and stakeholders. So on the right, you can see all our stakeholders, which are eventual consumers of this data, the dealers, the global agent, the clearing system, the swap counterparties with whom we do swap confirmations, the ISDA confirmations, and eventually the investors. So all of them are going to get a single digital golden copy of this data. And this brings to like what kind of guardrails or controls we have in place, because each issuer's data is confidential and needs to be secured as such. So in this whole process, we have implemented several guardrails in the architecture to ensure that issuance data is handled securely, it is validated rigorously, and delivered consistently across the value chain. So the first step we have taken in this regard is secure role-based uploads into the financial data lake. Um, so authorized users only can upload dealer term sheets through a controlled and auditable interface. So this is ensuring that only approved participants or approved traders can introduce new data into the platform. The second process we have built is that the confidential data is protected through a secured Azure OpenAI API container. Sensitive issuance information is processed within a dedicated and isolated Azure OpenAI environment. This ensures safeguarding confidentiality and inadvertently exposing our data to for external parties. Then the third step in this process of guardrailing is the metadata-driven validation and automated derivations. Shastra is using metadata rules built in the architecture to validate data types and their completeness. Then on top of that, we have built SQL-based logic that generates secondary inferred fields, which are interpreted from the primary data. So this is ensuring completeness and alignment with the required internal conventions which we have. Then as I mentioned earlier, we have the human in the loop validation. This is a structured review process which is built to ensure accuracy and precision, and combining the AI generated extraction with expert confirmation from a trader for high confidence and quality of this data. Then the fifth process we have built is the secure delivery of this processed metadata. So once it is validated, the standardized data from the Shastra web app platform is transformed using a Python environment into a secure, controlled dissemination channel through a secured dissemination channel, which is the Azure Service Bus. Then the sixth process we have built in the process or in the architecture is the production grade data persistence and transfer. All the data files which are created in Shastra are versioned and transferred through enterprise grade infrastructure. This ensures reliability, traceability, and long-term auditability of all the files which are generated in the process. And then eventually, when the data is captured in the Treasury core system, we have inbuilt another trade workflow layer, which is enforcing strict access control at that stage and performing trade economic checks, which are inbuilt in the Treasury core system to ensure that the deal is internally consistent and compliant with all the standards. So this brings me to the roadmap for Shastra. What do we aim to achieve with Shastra? Where do we want to go with Shastra in the long term? So as I mentioned earlier, the Shastra aims for end-to-end harmonization of the trade life cycle. And the way it is doing it is by digitizing highly fragmented legacy workflows for conventional capital market instruments. While we are doing this, we also want to ensure that the issuers who are the owners of their data or of the issuance data, they retain full control over their digitization efforts, and the automation of this process aligns with their internal processes, their internal guidelines, and their internal compliance requirements. Then what we also want to do with Shastra is standardized documentation. So Shastra provides opportunities for streamlined workflows, and in that process, generate standardized documentation. This will reduce manual effort and enhance consistency across the whole market value chain. Then, as I mentioned in the previous slide, we also want Shastra to perform structured trade data dissemination. All extracted and validated trade data is disseminated in a structured format, which is aligned with international standards. This is ensuring interoperability and trust across the whole ecosystem in the whole value chain. Then through Shastra, we also aim to perform knowledge sharing with stakeholders. We are in talks with our issuing and paying agent, the eventual data providers, And we are able to share the technical architecture, the design specification, and any underlying technology. And if it comes to that, even the Python code for our process or our tool, so that the issuers, who are the eventual owners of their data, using these low cost technologies, they are able to create their own solutions or replicate the same low cost solution for their own value chains. So with this, I'll pass it back to Emma.
Thank you. So for those of you that have found today's session particularly interesting, these are many topics that we discuss across the different work streams that we have at ICMA on fintech and digitalization. We look at data standardization in particular in the bond data taxonomy working group, which I referenced earlier. And that working group is also the key governance body for the maintenance and development of the BDT. So keeping the BDT an industry standard does require constant input from industry stakeholders to align us with those changing views that may occur. So over time, the Bond Data Taxonomy Working Group reviews and periodically develops different parts of the BDT. And it really aims to foster interoperability, as we've heard today, and straight-through processing throughout the life cycle in the bond market. We also have the AI in capital markets working group, which focuses on transformational implementations of AI across the bond market as well. And it also considers different regulatory considerations that may come up, as well as industry topics related to the use of AI in financial services. But we in particular like to focus on those implementations, and particularly as we have seen today, where we're seeing directed benefits of AI implementations as well. So both groups are represented by all ICMA market stakeholders and industry market stakeholders and are open to all members. So if you would like to get in touch to join either of those groups, please do reach out to us after today's session. And I did say I would touch on this earlier, and it's just to highlight that bond data taxonomy and the data standards that we produce are utilized throughout the life cycle. And as we have seen from the World Bank Treasury's Project SHASTRA today as well, it can be used throughout the straight through sort of process of bond issuance and post-trade processes as well. So recently we've seen the Hong Kong SAR government issue their third digital green bond utilizing the BDT. We've also worked closely with other organizations such as SWIFT and Euroclear and Clearstream on aligning the BDT with many of the data standardization projects that exist as well, and to keep the interoperability and the straight through processing of the capital market from start to finish. And moving on from that, I would just like to highlight the directories and resources that we have at the fintech team at ICMA. We list a number of different solution providers in the market, from the primary markets through to electronic trading, repo, and operations. And we also keep a tracker of new fintech applications on our website. So any AI implementations or DLT bond issuances as well, we track them all on our website to keep us informed and keep the industry informed of the new and innovative ways the bond market is changing. And so finally, I'd like to thank Rahul and Isha for their time today for this incredibly insightful presentation, and just to conclude with some of the key things that we've seen where Gen AI is really having an impact on the industry as it stands. It's helping to digitalize trade data from the source, keep its accuracy and align it across all systems with the use of data standards as well throughout, making sure that it is trustworthy and accountable going forward. Creating a single source of trade data has become that more attainable goal that we've all heard before, and it benefits all of the market participants from issuers, dealers to agents and investors as well. And the role of data standardization is only growing as AI adoption grows with it. So the BDT is supporting the adoption of AI application. It's helping to facilitate those standardized trade data tools and that standardized trade data format and streamline operations across the bond market. So I will hand back to Isha and Rahul to address any questions that have come up today. But like I said, if you want to reach out to learn more, please do get in touch with us. You can see our email on the screen there for ICMA, fintech@icmagroup.org, and we'd love to hear from you.
Thank you, Emma. So yeah, we have received some questions. Let me answer a couple of them. A question is that the Shastra only concerns the post-trade process, and what about the financing process itself? Is any AI tool used during the book building phase? So at the moment, Shastra is used for post pricing efficiency gains only. The objective is to enhance operational efficiency via workflow automation, as well as eventual data dissemination to all stakeholders. So at the moment, we are not using it, Shastra or any other AI tool during the book building phase. It's only being used for post-trade process. Isha, do you want to answer the questions on benchmarking data on error rates and how much time does the process save? And I think one additional question you can also answer together is, do you have to train the AI on all different types of term sheets the model will encounter, and does the performance vary between in sample and out of sample term sheet inputs?
Yeah, absolutely. So I can answer both of those questions, right? And then perhaps also the one that says, once AI is extracted, where do you store and persist the data for future use? So great questions, everyone. So so the advantage of using large language models, in our case, that would be OpenAI GPT-4o model, is that, and for our use case specifically, the term sheets don't usually cross more than 4 to 5 pages, right? So this, and along with the prompt, all of that fits within the good context length that the OpenAI models provide. Hence, we did not need to necessarily train the model with multiple documents for each of the trade types. Rather, we've been able to provide these documents, but have a very curated prompt instructions for each to introduce the instructions for each of these complicated or new type data structures or more structured ones. So each time we focus a lot on the prompt tuning and testing, and through across different term sheets, different trade types based on the different data that occurs in these term sheets. And that's how we've been able to see more progress and accuracy as we scale our model through different trade types. And on the question of where the AI data, once it's extracted, where it's stored is, so in one of the slides, if you remember, once we extract this data, and this is reviewed by the user for human in the loop validation, the data is then stored in our World Bank financial data lake for our document processes. Rahul, would you like to answer any other questions?
Yep. Okay. Yeah. Is Shastra used exclusively for paper trail swaps, or is it also applied to swaps executed through market wire? So at the moment, we are only using it for paper trail swaps, not for market wire trades. How much time is the human in the loop review gonna save for manual reconciliation or efficiency? So when this data is captured manually in the Treasury core system, there are some set templates which can be used for ready import of data, but still you have to browse through so many screens when trying to capture this data. While in this Shastra interface, you can have all the inputs available in one page with structured into different uh, instruments like the bond, the swap, and if there are multiple swaps, each of them in a different in a unified format for easy review for human in the loop. So this does save some time. Maximum it takes for a trader is 2 to 3 minutes for reviewing the data and submitting in the system, because you have both the extraction and the term sheet side by side. It's easy visualization and comparison. This definitely saves time. And the slides, not the slides, but the recording will be available on ICMA's website. In terms of rollout of the solution. Please do reach out to us if you have any questions on how you want to implement this on your side. And there's a question on the data providers. Please do reach out to us bilaterally, because I don't think this we can answer this in this platform, but we'll be happy to take those kind of questions bilaterally. And we are under discussions with all our counterparties, our stakeholders, of how this data can be disseminated to them, how they can use this. We have undergone some serious conversations, and the progress has been good so far. So we are positive that Shastra is gonna make a big difference in the whole value chain.
Great. Thank you so much, Rahul and Isha. It's been a pleasure having you with us today. I think we've all come away with some thinking points and some more topics to discuss going further. So I look forward to taking this conversation on and seeing how it progresses as well over the coming years. Like I said, and Rahul said as well, please do get in touch with us if you have any follow-ups on the ICMA or the World Bank Treasury side. A massive thank you to our speakers today and Gabriel as well. And we do have a FinTech Forum, ICMA FinTech Forum on the 9th of December, which is an event where we'll be looking at the impact of innovation on the bond industry, for example, through these AI applications in the industry as well. So we will be talking about this and much more in detail at that event too. You can find that on our website. Please register to attend and we can continue conversations there as well. But with that, just another final thank you to Isha, Rahul, and everyone for listening today. And we hope to hear from you soon.
Thank you for your participation, everyone.